This morning, millions of people woke up to a sky that looked wrong. Not stormy, not cloudy, wrong. The sun was dim. The air smelled faintly burned. Cities hundreds of miles away from any flame were covered in haze. And then came the alert. Stay indoors. Limit outdoor activity. The air may be unhealthy. But here is the strange part. For many of those people, there was no fire nearby. No burning forest outside town. No wall of flames on the horizon. No evacuation order. Just invisible danger floating through the air. So how does smoke from a fire in Canada travel more than 1,000 miles, cross a national border, move through entire cities, slip through windows, enter your lungs, and affect your body from the inside? The answer is not just about fire, it is about weather, chemistry, the shape of the atmosphere, and particles so small that once they reach you, your body may not know how to stop them. Because the most dangerous part of a wildfire is not always the flame. Sometimes it is what the flame leaves behind. A wildfire begins with something simple: heat, fuel, oxygen. A spark touches dry wood, grass, leaves, or peat. The material heats up, molecules break apart, gases ignite, flames spread. From the ground, a wildfire looks like destruction moving sideways. But above the fire, something else is happening. The fire is building an engine. As the flames heat the air, that air expands and rises fast. It pulls smoke, ash, gases, and microscopic particles upward with it. Imagine a giant, invisible elevator made of heat. At the bottom is the burning forest. At the top is the atmosphere. And if the fire is hot enough, that elevator can carry smoke thousands of feet into the sky, sometimes even higher. That matters because smoke near the ground behaves one way. Smoke high in the atmosphere behaves very differently. Near the ground, smoke may stay local. It can choke nearby towns, reduce visibility, and make the air immediately dangerous. But once smoke rises high enough, it can get caught in large-scale wind currents, and those winds do not care about borders. They do not stop at Canada. They do not stop at the Great Lakes. They do not stop because a city is far away. They move like rivers in the sky. This is the first piece of the mystery. The smoke does not simply drift randomly. It gets transported. High above us, the atmosphere is always moving. Different layers of air travel at different speeds and directions. Weather systems push, pull, lift, and trap air masses. A fire can inject smoke into one of those moving layers. And once that happens, the smoke becomes a passenger. It can ride over forests, lakes, farms, highways, suburbs, and cities. A fire burning in northern Canada can send smoke south into Minnesota, Wisconsin, Michigan, Illinois, Ohio, New York, and beyond. To someone on the ground, it feels impossible. How can a place with no fire smell like fire? But the atmosphere is not a wall. It is a conveyor belt. And when that conveyor belt lines up just right, smoke can travel enormous distances. But that still leaves the most important question. If smoke travels that far, why is it still dangerous when it arrives? Shouldn't it disappear? Shouldn't it thin out? Shouldn't the atmosphere clean it up? Some of it does disappear. Larger ash particles fall out. Some gases break down. Rain can wash pollution from the air. But wildfire smoke contains something much smaller, something that can survive the journey. It is called PM2.5. That stands for particulate matter, smaller than 2.5 micrometers. To understand how small that is, picture a single human hair. Now imagine something about 30 times smaller than the width of that hair. That is PM2.5. It is not one thing. It is a category of tiny particles, burned plant material, soot, organic compounds, chemical fragments, and other microscopic leftovers from combustion. And because they are so small, they do not fall out of the sky quickly. They can remain suspended. They can travel. They can slip through places larger particles cannot. And when you breathe them in, they do not behave like normal dust. Your nose and throat are good at catching big particles. That is why you sneeze. That is why mucus exists. Your upper airway is a filter. But PM2.5 is small enough to bypass much of that defense. It can move deep into the lungs, into the tiny air sacs where oxygen passes into the blood. And that is where wildfire smoke stops being just an air quality problem. It becomes a body problem. Inside your lungs are millions of tiny sacs called alveoli. They are delicate, thin, designed for exchange. Oxygen goes in. Carbon dioxide comes out. Every breath depends on that surface, staying clean and functional. But when fine smoke particles reach that deep, the body sees them as invaders. Immune cells respond. Inflammation begins. Airways can tighten. Blood vessels can react. the heart may have to work harder. For someone with asthma, COPD, heart disease, or another condition, that can be dangerous quickly. But here is the part people often miss. Wildfire smoke does not only matter for people who already feel sick. Even healthy people can feel it. A scratchy throat, burning eyes, a heavy chest, a headache, fatigue that feels strange because nothing obvious happened. The fire may be 1,000 miles away, but the particles are not. They are right there, in the breath. And this is why air quality alerts can feel so unsettling. You look outside, and there is no disaster scene, no flames, no sirens, no falling ash, just a number on your phone telling you the air is unsafe. That number is usually connected to the Air Quality Index, or AQI. The AQI turns invisible pollution into a scale people can understand. Green is good, yellow is moderate, orange is unhealthy for sensitive groups, red is unhealthy, purple is very unhealthy, maroon is hazardous. But the number is not the danger itself. The number is the warning label. The real danger is the concentration of fine particles in the air, especially PM2.5, and wildfire smoke can make those numbers rise fast. One reason is that smoke does not always spread evenly. It can arrive in waves. A city may look fine in the morning, then suddenly become hazy in the afternoon. One neighborhood may smell smoke while another barely notices it. Weather shift can push a thick plume downward and turn a normal day into an unhealthy one. That is because smoke moves in layers. Sometimes it stays high overhead, turning the sun orange but leaving ground-level air less polluted. Other times, sinking air pushes it down toward the surface. That is when people start smelling it. That is when visibility drops. That is when the particles enter the air people are actually breathing, and sometimes the weather traps it. Cities can sit under a lid of stable air where vertical mixing is weak. Instead of rising and dispersing, pollution gets held near the ground. It is like putting a glass bowl over a candle after the smoke has already filled the room. The smoke has nowhere to go. This is why a distant wildfire can become a local emergency, not because the flames arrived, because the atmosphere delivered the smoke, then held it there. But there is another strange part. Wildfire smoke changes as it travels. It is not frozen in time. As smoke moves through sunlight, humidity, and other pollutants, its chemistry can shift. Some compounds react. Some particles age. The plume becomes a moving chemical system. That means the smoke reaching a city far away is not simply old campfire smoke. It is a complex mixture that has been transformed during the journey, and depending on what burned, it can be even more complicated. A forest fire is not just trees. It can burn soil, moss, houses, plastics, vehicles, treated wood, power lines, and everything else in the path. Each fuel adds its own chemical fingerprint. That is one reason wildfire smoke can be more concerning than ordinary haze. It is not clean smoke. There is no such thing. It is a cloud of combustion products, carried by weather, concentrated by atmospheric conditions, and delivered directly into human neighborhoods. For most of history, people thought of wildfires as regional disasters. If your town was not near the flames, you were safe. That old mental map is breaking. Now a fire in one region can change the air in another. Smoke can close schools far from the burn zone. It can cancel sports games in cities that never saw a spark. It can send people to emergency rooms hundreds or thousands of miles away. The fire stays in Canada. The smoke becomes continental. And this is where the story gets bigger. Wildfires are natural in many ecosystems. Some forests evolved with fire. Some plants even depend on it. But the fires we are seeing now are burning in a different world. Hotter temperatures dry out vegetation. Drought turns forests into fuel. Earlier snowmelt can lengthen fire seasons. Heat waves can make fires more intense. And when fires become larger and hotter, they can send more smoke higher into the atmosphere. That does not mean every fire has one simple cause. Lightning can start fires. Humans can start fires. Wind can spread fires. Forest management matters. Building patterns matter. But the atmosphere surrounding all of it is changing, and that changes the odds. A warmer world can load the dice toward bigger fire weather, longer smoke seasons, and more days when people far from the flames still breathe the aftermath. This is the uncomfortable truth. You do not have to live in a forest to live with wildfire risk anymore. You can live in a city apartment. You can live in a city apartment. You can live near a lake. You can live 1,000 miles away, and still the smoke can find you. So what do you do when the sky turns gray and the fire is nowhere nearby? First, understand that smell is not a perfect warning system. If you can smell smoke, that matters. sputters. But dangerous particles can also be present when the smell is faint. The better signal is local air quality data. Second, staying indoors helps, but only if indoor air is protected. Windows open, leaky buildings, poor filtration, and constant door traffic can let outdoor particles inside. Third, masks are not all equal. A loose cloth mask may stop droplets, but it is not designed for fine wildfire particles. A well-fitting N95 or similar respirator is much better at filtering PM2.5 when someone has to go outside. Fourth, exertion matters. When you run, exercise, or work hard outside, you breathe more air. More air means more particles entering the lungs. That is why officials often warn people to avoid strenuous activity during smoke events. But the deeper answer is not just personal behavior, it is preparation. Cities that once planned for snowstorms, heat waves, and hurricanes now also have to plan for smoke. Schools need indoor air plans. Hospitals need surge awareness. Homes need filtration. Workers need protection. Public alerts need to be clear before the air becomes visibly bad. Because wildfire smoke is not dramatic in the way television expects disasters to be. It does not always arrive with a wall of flame. It arrives quietly. A dimmer sunrise, a strange smell, a warning on your phone, a breath that feels slightly heavier than it should, and by the time you notice it, you may already be inside the plume. That is what makes this story so powerful. The smoke is both distant and intimate. It begins in a burning forest far away. It rises into the sky. It catches a wind current. It crosses lakes and highways and borders. It passes over millions of rooftops. It sinks into a city street. Then someone opens a door. Someone takes a breath, and a particle smaller than a speck of dust completes a 1,000-mile journey inside the human body. That is the new reality of wildfire smoke. The fire does not have to reach your home. The atmosphere can bring the fire to you.